I'm James Hughes, bioethicist and resident techno-progressive.
And I'm Eisikovits, philosopher and resident Luddite.
And you're listening to Prosthetic Gods, an optimist and a grump on tech, a podcast where we explore the social, ethical, and political impacts of emerging technologies. This week on Prosthetic Gods, Nir and I are speaking with Avi Loeb. Avi is an astronomer, an astrophysicist at Harvard University, former chair of Harvard's astronomy department, known for leading the Galileo Project to find extraterrestrial life, Harvard's Black Hole Initiative, and he is the author of many provocative theories about the possibility of alien technology, such as the current debate about Three-Eye Atlas that we're going to be discussing today. He's the author, most recently, of Interstellar, The Search for Extraterrestrial Life and Our Future in the Stars. Welcome, Dr. Loeb.
Thanks for having me. It's a great pleasure.
So if you could briefly describe the Three-Eye Atlas and what the difference between an interstellar asteroid and how Oumuamua kind of set the stage for this, and just set the stage for what we're going to be discussing.
Well, first, I wanted to mention that I'm wearing a tie on your podcast that is a different color than the ones I wore in recent months. And that's the reason for that is simple. Some creators produced a YouTube channel that imposters, me, and basically is in my name and talks about the same topics, of course, with content that I do not approve. So it's all fake and fabricated. And the reason I bring this up, it's a challenge that we will have in the future when we get content from online. And the question is how to authenticate what we are looking at. And my advice to young people is always go to primary sources and check. A lot of people got used to using AI agents for accessing information, and that's a very risky business, especially in academic work. And I usually advise young scholars to think rather than use AI agents to provide them with the information. And because some of it is hallucinated, some of it is false, fabricated, and there are creators who are trying to benefit from AI by even submitting scientific papers that are written by AI systems. And that's a big risk for the future. So at any event, if you see me in the coming weeks with a tie other than blue, then you know that it's fake. And then, of course, if someone makes a video with AI generator that has me with a blue tie, I'll change my tie as well, again.
But that's an excellent point, because as a philosophy podcast, one of our principal concerns here is the epistemics of, or epistemology of this. And you're pointing out that an open mind should only be so open. And that's one of the things we want to dig into here.
Right. I mean, my argument is more in favor of natural intelligence over artificial intelligence, as much as it's tempting for us to use it. I mean, it's very useful to replace administrations, bureaucracy in universities, in organizations. I'm very much in favor of cutting down the administration, academic administration, and, beefing up the scholarship. In place of that. With respect to philosophy, I've been arguing for a while that the humanities should be changing their themes instead of focusing on ancient philosophers and people who thought, in previous centuries. We should think about the humanities of the future, meaning what are the ethical standards and the guardrails that we should put on technologies of the future, in particular artificial intelligence, which, the interface between humans and AI is a completely new territory. Martin Buber, a century ago, was talking about three types of interactions of humans: with physical objects, human-human interaction, with God. And obviously that was before Alan Turing invented the first computer, and he could not have envisioned that there will be a human AI type of interaction that is completely different. It's, we're interacting with a digital mirror that is able to access all content online, and has a lot of junk intellectual food that it can feed us with. And just like, junk food is bad for the health of our body, junk intellectual food is bad for the health of our mind, our brain. And that is a big issue for the future. And I'm worried about the effect of AI on humans. AI may become more intelligent, but humans will become dumber as a result of consuming this junk food. And I think humanities have a responsibility to attend to this challenge, and with all the ethical standards applied to this new technology. And there is a lot to be done, and that would make the humanities far more relevant for society. And humanity is all about the human aspect, which I admire much more than the digital aspect of our life these days.
Yeah, apropos that specific point of focusing on a philosophy of the future, as I listened to you and read some of the interviews you gave, some of the rationale for focusing on 3i Atlas and focusing on interstellar visitors, and for that matter, some of the rationale for the Galileo Project, is this kind of philosophical argument, as I hear you make it, which is if the small chance realizes, and these do happen to be technological civilizations trying to get in touch, all the ways in which we think about ourselves are going to get stood on their head and change completely. And as a result, even if it's a minuscule chance, it's this kind of black swan event that's worth pursuing. Is that a fair characterization?
Yeah, this is something that scientists fail to understand, which is, just to give an example, there was about $90 million invested in 2 experiments in recent years to search for some ghost particle, a sterile neutrino. And this week, actually, the reports came out in Nature magazine that the search failed. There was no evidence for sterile neutrinos. Okay, that has very little impact on society. It doesn't change the daily routines of people. And as a result, scientists can be wrong on such matters. Who cares? Like, if there is a star exploding at the edge of the universe and the interpretation is wrong, just because astronomers insist on some narrative, but it turns out to be a different reality, no harm is done. And scientists are used to that. And partly it's because they separate themselves from society. They put themselves on a pedestal, and they decide what to do with the money, which subjects are more interesting intellectually. We will search for microbes. We don't care about whether the public wants us to find intelligence out there. These are the priorities of astronomers right now. Search for microbes. More than $10 billion of taxpayers' money, 0 is allocated to the search for technological signatures. That's considered completely legitimate within academia. And so part of that, the other side of the coin, is that what scientists are doing are very often irrelevant to society in terms of immediate applications. It could be in a century, 2 centuries. There is always this notion that whatever is now being discussed might later become applicable. It's not always true. A sterile neutrino would never be useful in any way. But anyway, the reason I bring this up is the situation is quite different in the context of a visitor to our backyard. If you have an interstellar object like 3i Atlas, and it turns out to be alien technology, everything will change. And even a small probability for it being technological must be regarded seriously, because the implications are huge. Why do I say that? Because that's what the intelligence agencies are doing. They didn't do it on September 11. They said, oh, what's the chance that someone will hijack an airplane and run into the high rise in New York City? That has a 0 chance, and nobody.
Yeah.
The same true on October 7th. in Israel. I mean, the intelligence agencies had the data and they completely ignore it. Why? Because the likelihood was small that something like that would happen in the minds of the intelligence officer. Now, the same is often true in the context of science. You say at the 98% confidence level, I know that, this object must be a comet. Why? Because I see gas around it. Well, but a spacecraft could also accumulate ices and dust along its path in interstellar space. So just finding, you cannot judge a book by its cover. Just finding some superficial signatures of something familiar doesn't mean that, like, for example, suppose you see a dust cloud in the desert, and you say, okay, well, I'm used to the fact that such clouds are being generated by an animal, therefore it must be an animal. No, a car can do also the same thing. So the superficial conclusion that at the certain high likelihood something is, a comet, while it's completely legitimate in the standard practice of science where the implications are negligible to society, in the context of alien technology, you can't take that chance. Why? Because if they are superior to our technology, we might feel if we are not prepared and not ready for that, it would be it could be a very risky situation for us and therefore we must consider a black swan event. So all that it means is we will collect as much data as possible to make sure that it is a natural object, a comet, and not anything that is a potential threat to humanity.
But as I understand your argument, it's not just a Pascal's wager kind of argument that even if it's a vanishingly small chance, it would have such consequences that we should consider it. Your argument is that looking at this object, there are things about it that suggest over time that we should be updating our assessment of the probability that it's a non-natural object. And what are those things that you have noticed?
Exactly. No, I mean, there was a previous, this is the third interstellar object. And the previous one, I didn't raise the alarm because it looked just like a comet. In this case, there are some anomalies. Okay. So what are the anomalies? Well, first of all, this object is traveling exactly in the plane of the planets around the sun to within 5 degrees. And the chance for that happening at random is 1 in 500. And then it comes very close to specific planets. Mars, for example, it came on October 3rd, within 30 million kilometers. It will come close to Jupiter within 53.5 million kilometers on March 16th, 2026. And the chance of those things happening at random is very small. We calculated, 1 in several tens of thousands. And on top of that, it sheds nickel with very little iron from its surface. And the only place where we find that is in industrial production of nickel alloys. So that suggests maybe it's technological. We see a lot of jets coming from it, some towards the sun, some away from the sun, some sideways. And it's not, we can, in principle, by collecting more data, figure out if it's the sublimation of pockets of ice on the surface of a rock or maybe technological thrusters. So my argument is there are some anomalies, things we don't fully understand, why there is an antitail, a glow of gas pointing towards the sun rather than away from the sun, the way we find in comets. And these are things that were not found in comets. Usually the gas and dust are being pushed by the solar radiation, the solar wind, and pushed away from the sun. And here we see this starting from the beginning. We saw this jet from the object towards the sun. We also see it in the latest Hubble telescope image after the object passed closest to the sun on October 29th. So it seems to be persistent. Now it's opposite to the direction of motion as the object is receding from the sun, and it was originally in the direction of motion. So anyway, these need to be thought about, understood, but also the most important thing, I'm trying to motivate the collection of data because that's the only way by which we can figure out for sure whether this blind date that we have of an interstellar object is a blind date with a friendly visitor or unsuspicious visitor, or maybe with a serial killer. I mean, how do we know that? And we all know about the Trojan horse story, and it did look completely innocent at first sight to the residents of the city of Troy.
People pointed out that some of the stuff coming off of this object could, in fact, be little satellites that they're sending out to do observations. And another thing that just happened is that the MAVEN satellite, as soon as it took an image of 3I Atlas, NASA lost touch with that satellite. Do you think that that is significant at all?
Well, so I write updates, essays on medium.com every day or two, and indeed, I included these updates. I have more than 5 million readers per month. And so the MAVEN loss of signal occurred about 2 months after the passage of 3I Atlas close to Mars. And, it's really strange because this spacecraft was operating for 11 years. There was no hiccup, no previous indication of a problem, but it may also be a coincidence, of course. Indeed, I mentioned in many of my essays the possibility that the object itself may not maneuver to come close to a planet, but it may leave probes or devices that visit Mars, Earth, or Jupiter, and we should keep an eye on that. And maybe with the Mars Reconnaissance Orbiter, we can still look and check if there are any new objects around Mars. And the same can be done with respect to Jupiter, because it's coming exactly at a distance where Jupiter's gravity dominates over the sun's gravity, which is a very special distance. It's called the Hill radius around any massive object, where its gravity starts dominating. And for some reason, 3I Atlas will arrive to Jupiter exactly at that distance. And one possible reason is that it may want to deploy devices. That's what we did at the second Lagrange point around Earth when we placed the Webb telescope there, because it requires very little fuel to keep it there. And the same may be true around Jupiter for if 3I Atlas is technological. So I'm just saying, let's keep an open mind and collect as much data as possible. And the experts, the comet experts, insisted, even before we had any data, just by seeing this 3I Atlas enter the solar system, they immediately said it's a comet. And this is, I can easily understand that, because they operate just like AI systems. They have a limited training data set, which includes only icy rocks in the sky. And so they interpret any object in the sky as an icy rock, because that's what they're used to. And my point is, we know that there aren't only icy rocks in the sky, because we launched equipment to space. And therefore, I'm begging them to expand their training data set to include such objects, because we might not be the only technological civilization. The sun formed in the last 1/3 of cosmic history. Most stars formed billions of years before the sun. There was plenty of time, even for the technologies that we used in the 1970s that we used with Voyager. It takes Voyager less than 1 billion years to move to the opposite side of the Milky Way galaxy. There is plenty of time for them to arrive at our backyard, and therefore we should be open-minded and search for that. And
Avi, let me ask you just specific follow-up on that. For you, what would it take to disprove that 3I Atlas is of a technological origin?
Oh, it's really simple. In the coming weeks, we can use spectrographs on telescopes to measure the speed of the gas in the jets coming from 3I Atlas. And if that speed is below several hundred meters per second, that's fully consistent with pockets of ice being warmed up by sunlight and vaporized into these jets. However, if the speed is much bigger than that, then it has to be technological thrusters that produce such jets, because rockets operate at a few kilometers per second speeds, and ion thrusters operate at several tens of kilometers per second. So So it's a very simple test, and also the composition of the jets will be quite different depending on whether it's technological or natural. And once we know that, then I think we can also gauge how much mass is being expelled from the object, and it may not be just the surface or the skin of the object, maybe a substantial fraction of its mass that is spewed out in these jets, and then it would be clear that it's natural if it is natural.
So,
So
from the just to follow up on something that Avi was saying earlier, so from the response of your colleagues and from what you said earlier about cosmology, it sounds like the scientific culture in astronomy is a lot more conservative than the scientific culture in cosmology. Why is that?
Yeah, indeed, the way I refer to it, I mean, I started in studying the universe, cosmology, and now I'm doing some work in relation to space objects near Earth. And I would make the comparison between chess players, in the context of the universe. We don't know what most of the matter is, most of the energy is. We call it dark matter, dark energy. And when I started practicing astrophysics about 40 years ago, it was very much encouraged to come up with innovative ideas for what dark matter might be, and because then experimentalists would test them, and there was no ridicule associated with a conjecture. However, in the context of space objects, I get a lot of insults, personal insults, when I bring up the technological possibility. And the way I refer to these practitioners of science is as mud wrestlers rather than chess players. And I don't want to get dirty. I don't like being dragged into the mud. So I really find that completely inappropriate in the context of science. And, it's really unfortunate because it sends a very bad message to young scholars. Basically, don't deviate from the beaten path. And that, unfortunately, you might say, oh, well, maybe the beaten path is the right path. Maybe being conservative is a good approach for the mainstream. And the answer is no, because we know of several recent examples where the mainstream went in directions that didn't lead anywhere. I gave an example of the sterile neutrinos just this week, reported, not a good idea. They are not there. Supersymmetry, since I started, was a new symmetry of nature advocated by the people who claim to be leading physics, especially string theories. And it was not found in the natural parameter space by the Large Hadron Collider that cost about $10 billion. String theory itself, you have a community of thousands of people doing intellectual gymnastics, mathematics, I mean, for more than 40 years. Now, not only that their ideas cannot be tested or proven or disproven experimentally, there is no idea for any future, or they don't feel even a need for any future experiment to validate what they're doing. Moreover, even the theory itself is not sufficiently specific and unique to make a prediction. So you ask them, what happens inside a black hole? They say, I don't know, it's complicated. What happened before the Big Bang? We don't know. It's too difficult. So my point is the mainstream, which you might say, oh, is conservative. No, in this context for 40 years, they are focusing on an idea that, of extra dimensions. We have no clue whatsoever if this idea applies to reality. And they created a big enough community so that they can give each other awards and justify psychologically. All of them working on it. You ask, what is the difference between that and a cult? I mean,
but part of the conservatism comes from the concern astronomers have of the reputational damage if they're associated with something like ufology. And now there's a growing empirical interrogation of whatever evidence there may be for unidentified aerial phenomena. Do you see what is the relationship in your mind between looking for technological signatures in other solar systems, looking for a technological signature of an interstellar visitor like 3I Atlas, and looking at empirical evidence of unidentified aerial phenomena? Are those three entirely different things?
No, I mean, they could be related, as we discussed before. There could be gadgets that were released in the past or will be released by interstellar objects and come close to Earth and appear as unidentified anomalous phenomena. The problem is there is a lot of crap, a lot of people who make unsubstantiated claims. People who claim, we were abducted. Okay, so they just tell you stories, or there is this and that incident. The point is, this is not quality data that is substantiating those claims, and that there is a lot of noise because people like to discuss this subject. Now, this doesn't mean that scientific inquiry should not address this subject because, back 1,000 years ago, a lot of people said that we should not operate the human body because it will hurt the human soul. Okay, that was a philosophical idea. If you open the human body, you can hurt the soul of a person. Now, go to Mass General in Boston. Nobody's soul is being hurt by doing the appropriate procedure to resolve a medical issue. So clearly this idea was completely wrong, but it was popular and a lot of people believed in this nonsense. Okay, so the same is true on the subject of UFOs. You have even more nonsense being said, but that doesn't mean, for the same reason the medical profession became scientific, it doesn't mean that science should not apply to this subject. So if there are objects near Earth, we should be able to find them with scientific grade instruments that are well calibrated and with data that everyone can look at. Now, if the US government has such data, I'm all for it to share this data with scientists, because anything that came from beyond Earth, is not a matter of national security, okay? And especially if they have any information from 50 years ago, if there is no risk that a technology from an adversarial nation would be relevant today, so it cannot be classified. One reason for things being classified is because if the intelligence agencies or the Pentagon are being embarrassed by the fact that they cannot really figure out something, they would prefer to classify it. Why? Because nobody can look over their shoulder and say, you didn't do your job. We're putting $1 trillion a year in the defense budget for 2026. Nevertheless, there are objects in the sky that you cannot identify. Nobody wants to hear that. So they keep it classified, so not many people know about it. However, if there is any information that relates to what lies outside the solar system, that's my day job. That's information that humanity as a whole needs to know. I mean, when you sit at the dinner table, if you as a parent know that you have a neighbor, you would disclose this information to your family members. It makes no sense to hide information about your neighbors from your family members. It's also possible the government has no such information, in which case they are perfectly okay in the way they deal with it.
Are you concerned sometimes, Avi, that as you said, on the one hand, there's an argument for bringing the rigorous scientific method to a bunch of topics, even if there are topics of public fascination, and you're doing it. And I at least think you deserve a great degree of credit for it, for being willing to put up with a good amount of ad hominem attacks in the process. Is there a risk, though, that the people who are, as you put it, purveyors of nonsense and alien abductions and so on and so forth could sort of use your academic legitimacy in ways, I'm assuming that's already being done, in ways you're not interested in? So is there, how do you balance the fact that there's an argument to bring science to even topics of public fascination on the one hand, and on the other hand, that a lot of the practitioners of public fascination are flaky and not serious?
You see, whenever you do something significant, there are parasites. The same is true for a whale that is, a very big animal. There are lots of small animals, taking advantage of the whale, as it moves through the water. And so we should not be deterred by these parasites. I mean, I pretty much have no footprint on social media. I was on Joe Rogan's podcast, and he said, thank God for that. And I said, don't thank God, thank my wife, because she is the one to convince me that I shouldn't have it. And I don't really care what other people say. That's completely irrelevant. I'm trying to use common sense and also the scientific method, which we know demonstrated a lot of progress in the way we live today. I went to Copenhagen at the end of August for a conference at the Niels Bohr Institute. And I entered the auditorium. It looked familiar because that was exactly the place, Auditorium A, where quantum mechanics was conceived. There is a famous photograph. So I sat on the bench and someone said, "Oh, you're sitting in the same place where Wolfgang Pauli sat back 95 years ago." And all I could think was how uncomfortable is this wooden bench. Their quality of life was very low back then, 95 years ago, compared to now. Why do we have so much better life now? Because of their accomplishments. The discovery of quantum mechanics improved our life tremendously. All the technologies we're using, electronics, the way we communicate and so forth. And the medicine evolved dramatically, and science basically brought a lot of progress, and therefore, the benefits at the end of the day, the benefits outweigh all concerns about parasites taking advantage. Of course, any new technology can be used for bad purposes. We know that from the atomic energy, as it was discovered. We know that from many other things. So you have to live with that. It's part of it's a feature of the territory that we have to live with as we make progress, and I'm willing to accept that. And so I'm not getting offended because it's not about me. The message I'm trying to convey is so important for the future of humanity, because imagine that we have a neighbor, imagine that we will encounter alien technology. It will change everything in terms of politics, in terms of what we aspire to do in the future and exploring space, and in terms of our religious and philosophical beliefs, everything will change. So yeah.
Well, one of the big problems with SETI has always been that we have to estimate that the average age of a civilization, or the length of a civilization's life, is relatively short compared to the length of time in the universe. We've probably been emitting technological signatures for 100 years, 50 years. And this object that's coming at us is what, 4 billion years old as our planet?
We don't know the exact age, but it could be 10 billion years old. Older than the sun by a factor of 2 or so.
So just to rewind to one of the anomalies you mentioned, was this coating on it that appears to be nickel, and as opposed to what most comets that we see that are not interstellar comets are made of. And some people have suggested that may be because of its age, that it's been bombarded by interstellar radiation for billions of years.
They're just suggesting, but they haven't proven it. We don't know the exact age of this object. The one important point related to what you said is that traditional SETI was all about detecting a radio signal. And that is just like waiting for a phone call at home. Nobody may call you from your neighborhood. And as you said, if they are short-lived, you have a very narrow window. You have to be at the right time listening to their transmission. Might have been a lot of tragedies in the history of the Milky Way galaxy, where civilizations came and were, and perished after a few million years, and we were just not aware of that. And here we are, and we are about to obviously embark on the possibility of inflicting destructive wounds on ourselves with AI and other technology. So we might disappear. So detecting the radio signals is not really the best approach. Instead, you can look for a package that arrives at your mailbox, and the sender may be dead by the time you detect it. It's still there. I mean, all these objects are bound by gravity to the Milky Way galaxy. So unlike signals of light, they do not escape and be out of reach for us. And so it's a very different approach, and that's why I'm promoting it. And the interesting thing is the SETI community itself is very hostile to this subject, as if they are trying to justify to someone else that they are more conservative than anyone might think. And it's really strange, the psychology of that, because I would think that they should be thrilled at the fact that now, the subject gains a lot of popularity, a lot of people are discussing it. It's quite amazing the kind of letters I get from parents that say, after hearing you, because of you, they tell me, my kids heard you on television, podcasts, and so forth. They want to become scientists now. And how often do you get kids to want to become scientists? So it's really strange that the SETI community is hostile, and among the most fierce critics of what I'm doing are SETI people. I can give you a lot of examples, but let me just mention one. I wrote a paper saying, by the way, I'm not a science popularizer. I'm not Neil deGrasse Tyson. I'm not talking about work that other people are doing. I'm actually doing the work. Okay, so shortly after 3i Atlas was discovered, it was discovered on the 1st of July, and my wife wanted to go for a vacation, 4th of July, but I took several hours off the vacation to write a paper because this object was bright, and I wrote a paper saying, it looks like it's big because it reflects a lot of sunlight. If it's big, then it might have targeted the inner solar system, and it's not just a rock in interstellar space delivered, because there is not enough material in interstellar space to deliver such a large rock the size of Manhattan Island once per decade. And so the editor of the journal, this is an astrophysics journal, he said, I will accept the paper for publication. That was just a few days after 3 Atlas was discovered. He said, I would accept it for publication if you take this last sentence out of the paper. Basically, I don't want any technological aspect of this object to be mentioned. This is a person, by the way, the editor, who works on SETI. Okay, so I took it out, and then, of course, a week later, I worked on a paper that was dedicated to the technological, because censorship has no place in science. I mean, we didn't have much data about the object. How can you just ignore that possibility? And so this extended paper that was much bigger than one sentence was accepted for publication in a peer-reviewed journal. But the same editor went out to the New York Post and said, this is nonsense on stilts. And this editor didn't say that sterile neutrinos or ghost particles are nonsense on stilts, even after they were disproven by experiments. So now we know that they're not real, and we invested $90 million in the search for them. So how come this is not nonsense on stilts and a new object to the solar system? And by the way, there cannot be an expert on interstellar objects, because before this object, we had only 2 objects that we knew about before this one. So you can't be an expert on a completely new population of objects. Nevertheless, this editor expressed his very strong opposition. And of course, he has a student that will never dare to bring up that possibility, of course, because then the prospect of that student to get a job would be minuscule. And so the real danger is that people will be afraid. The young people are afraid of innovating and thinking outside the box. And this is perhaps why we don't have as much progress as we had when quantum mechanics came along, and people were more open-minded. Now, if you look at the Nobel Prizes, they're always about ideas that were initiated, 50 years ago, 100 years ago. Very little out-of-the-box thinking today that is really disruptive.
Avi, let me ask you about the Galileo Project. So the Galileo Project is a project that you initiated for using the best technology that we have, the best technological sensors that we have, to look for technological signatures in the close by neighborhood and low Earth orbit, or close to that. And as I understand it, having heard you speak in the past of the Fermi paradox, that's your way of trying to sort of actively resolve the Fermi paradox about where is everybody, which is the answer being, I don't know, let's look for them and see if we can find someone, rather than ask where, sit quietly and ask, where is everybody? So I wanted to ask you, first of us, to tell us why you decided to initiate the Galileo project rather than try to raise money for more kind of work like investigating 3A Atlas. I know that they're not mutually exclusive, but still, that's where you put your energy. And second, I wanted to ask you one concern I have about the way you framed things earlier is you're right that if by chance we do discover technological signature through the Galileo Project, for example, everything will change. But you seem to think that it will change for the better, and it might change for the worse. We might be ants to them, and then we have a problem.
That's certainly possible. So let me answer your first question first. It was a response to the fact that the Director of National Intelligence delivered the 3 reports to the US Congress talking about unidentified anomalous phenomena. And to me, it sounded like a serious matter because, the minimalistic interpretation of that is to say that the adversarial nations are using objects that we cannot figure out. So actually, the Pentagon is not doing its job. There are things flying in the sky, and we know about it because there was the Chinese spy balloon that was first noticed by citizens and then brought to the attention of government that eventually shut it down. And so the possibility that our national security is compromised by adversarial nation is a very serious matter. Okay, and so obviously the intelligence agencies would prefer to lower any the prospects of any admission that they're not doing their job, and so they would try to avoid mentioning that. But the fact that 3 reports came out means that that this is a serious matter that they cannot really ignore. And so my point is, we have a duty as scientists to figure out if there are objects near Earth that may not be human-made, because if I am leading the Galileo Project and we build the observatories, we have 3 observatories that we built, one in Massachusetts, another one in Pennsylvania, and the third one in Nevada. If we, at the end of the day, we look at millions of objects every year and use machine learning software to look for outliers and find that all of them are human-made, the Pentagon can use our detection method, they can use our software. So I would feel that time was not wasted because in principle, they can benefit from that for national security. Okay, so I'm just doing what I should do as an American citizen to help government figure out the nature of these objects. It's not a waste of time. However, if we do find something extraterrestrial, then of course it's the biggest discovery ever made in science and would have huge implications. That would be just the cherry on top of the cake. And so that's the reasoning for me doing it. I don't feel it will be, we can't be in a situation where it will be like not finding a ghost particle where you allocate a decade of your life for a task that ends up at a dead end, like nothing came out of it. And then to your second question, my philosophy is that if I have cancer, I want to know it, even if it's bad news, because being aware of reality allows you to adapt to it in the best way you can. If you are not aware of it, you might not do the right things. Therefore, being realistic is always beneficial, in my opinion. And the thing I compare it to is being in love, because when you are sincerely in love with, let's say, another person, and not with an AI agent, with a person, you want to know as much as possible about that person, all the faults of that person. If the person has a problem, you want to know that because you are in love with that person. So each and every detail has to be known. And to me, my work as a scientist is because I'm in love with nature. I really want to know the physical reality that we live in. And that includes our cosmic neighborhood and knowing if we have a neighbor, if we have a sibling to our family of intelligent civilizations. And I wouldn't be worried about the religious implications of that because, I have 2 daughters. And when the second one was born, it didn't take away any of the love that I had to the first one. So just imagining that God can attend only to one child is really very limiting. I mean, I don't think there would be any issue to religions when we realize that we have siblings Uh, the only issue is that we might be jealous of some of these siblings that are more accomplished than we are. The way I think of it is that it will inspire us to do better. Because right now, just think about what we are doing. If you read the news every day, we engage in conflicts about territories, small pieces of land on the surface of a rock that was just debris left over from the formation of the sun, a tiny rock. Now, there are 100 billion stars like the sun in the Milky Way galaxy, and 10% of them have roughly, have planets the size of the Earth, roughly at the same separation. And you just ask yourself, where is most of the real estate? Most of the real estate is out there. And yet we, as a very non-intelligent species, keep fighting on territories on this tiny rock. I mean, what about looking up and thinking about the big picture? And we lose sight of that. And the only thing that can restore us to the correct perspective, cosmologically speaking, is to realize that we have a neighbor that did much better and managed to reach our backyard before we reach their backyard.
So you have a busy 3 months ahead of you. With this next week on Thursday, the object will be closest to Earth, so we'll get a very good look at it. And you said that it's a new moon, so we won't even have moon light to interfere. And then it'll get close to Jupiter in March. And one of the things that you're looking for is whether it navigates around Jupiter to use a kind of gravitational slingshot to go wherever it's going to go. And some of the jetting that you're looking for will be, is it trying to navigate in that way? Is it doing something anomalous in terms of its direction? Is that right?
Yeah. It's most likely, I would still say that it's most likely a natural object, but I defined a new scale that is called the Loeb classification scale, where 0 means a natural object and 10 means a technological object that is potential threat to humanity. And initially, I ranked it 4, meaning it's most likely natural, but there is a substantial chance that these anomalies may indicate technology. And I'm being asked all the time. Every day I have 4 to 10 interviews. I'm asked about my new rank, and I'm waiting for this data before I can bring it down to 0 or maybe closer to 10, depending on what we see. But as of now, I would say you can sleep well at night. There is no clear evidence for any maneuver or release of smaller objects as of now. But we have to keep our eyes open. That's all I'm saying. And this is not a popular view among the scientific community. So I think it sheds a lot of light, first of all, on the fact that science can be attractive to the public. I can definitely testify to that fact. If you are open-minded and you are willing to engage in possibilities that do not represent past knowledge, the public cares about it. And moreover, kids want to become scientists under these circumstances, which are very different from what the message you get in press conferences when scientists just lecture to the public what the public should know. That's a very different approach. And then the second thing is that there is a lot for us to learn, and we should approach it with humility. That's the fundamental standpoint. Humility is extremely important, because my point about science is that the foundation of science is the humility to learn. It's not the arrogance of expertise. And what you see over and over again when you speak to scientists is the arrogance of expertise. Even when they correct course and say, we were wrong about something, let's say COVID, whether COVID came from a lab or not, anything that you choose in which scientists change it. I mean, even, whether we should drink red wine or whether there are lots of things where science changed course, changed direction. That doesn't bother the experts. They still maintain the arrogance of expertise. And I argue that this is bad for science. This is bad publicity, because it puts science as an occupation of the elite that doesn't really care about correcting course based on feedback. And it also is bad for innovation in science, because science should be viewed as work in progress. And it's not about us being smart and being right and being admired. It's about figuring out nature, not about us. It's about figuring out nature and figuring out the reality that we live in.
So Avi,
Yeah.
if I understand sort of between the lines correctly, in the Galileo analogy, the Vatican is analogous to the scientific establishment, to the sort of regular academic establishment, the one who sort of will wants to silence Galileo.
Well, that's the question that an Italian reporter asked me after Oumuamua was discovered, the first interstellar object that was anomalous in other ways. And when I suggested that, I was attending a conference a day later. I went to Germany. There was the Falling Walls conference there, and there were so many reporters that wanted to speak with me. They put all of them in a small room, and just because there was no time for individual interviews. And as I entered the room, an Italian reporter shouted from the back of the room, "Do you think you are Galileo?" And
See,
I
I
said,
didn't ask
"No."
that. I just asked who the Vatican is. I was
And
trying to be more tactful.
I said, "No, I don't, it's not, I'm not that, it has nothing to do with Galileo. It's just that there is this object that is strange and we have to figure it out. Let's keep our eyes on the ball. People always associate the discussion with individuals who are bringing with the messengers. It's not about the messengers, it's about the message. And why can't we be open? Like, how bad could it be if we collect a lot of data on 3i Atlas and end up finding that it's a rock? It will just serve us well, because we have an object that arrived at our backyard after traveling billions of years through space. It would take any spacecraft we launch billions of years to reach the source of this thing. And we can learn a lot about that environment where it came from, even if it's natural. We can, for example, if we were smart enough, we would dig into it, bring a sample of material to Earth, and and examine whether the building blocks of life exist on it. Lots of things. I mean, I think it's a new frontier. And the one thing I should tell you about myself, I mean, I actually wrote an essay about it this morning. When I started astrophysics, it was completely an arranged marriage. I was not interested. I was interested in philosophy, actually, just so that you know. But circumstances brought me to astrophysics, and the person who offered me a 5-year fellowship at the Institute for Advanced Study at Princeton, John Bacall, he said, just after he made the offer, he said, "Which computer codes have you developed during your PhD?" And I said, humbly, I said, "Sorry, John, I did not develop computer codes. I just use the computer when I need to solve a set of equations that does not have an analytic solution. I really try to minimize my time with a computer." And that was in 1987, okay? And John said, "How do you expect to have a scientific career without developing your own computer codes?" And he, at the time, did not fully realize that my main skill, which is to think differently than other people. So, very often young people come to me, like students, postdocs, even faculty, and they tell me about what they're doing. They come to my office and say, what they're working on. And I say, "Have you thought about this idea?" And they said, "Oh, no, I haven't thought about it. It's really interesting. I've never seen it discussed. Let me look into that." And then they spend years working on it. That happened to me many times. And also yesterday, 2 people came to and I mentioned it in my essay, so I'll not repeat those examples. So what I find surprising is I have ideas bubbling in my head all the time. It doesn't cost me. I mean, people come to me within seconds. I ask them the question. It doesn't require any effort on my behalf. I'm not particularly proud of that. But then what I'm surprised by is that they haven't thought about it, that in fact people in the literature haven't thought about it. And it's not clear to me, because these ideas are a matter of common sense. And by the way, what I say about 3i Atlas and the possibility, attending to anomalies, to me, it sounds like common sense. I'm not trying to be different, but for some reason, the ideas that I come up with appear not to be a matter of common sense in academia. So what I say is that common sense is not common in academia. I have no other way to explain it. But that allowed me to have a successful career. To answer John's question, it was not about developing computer codes. And by the way, now AI can develop codes much better than humans. So I'm really happy now. Maybe I was 38 years early, but I feel that the threat of AI taking my skills is much lower than the skills of code developers.
Yeah. Um, if somebody gave you $1 billion tomorrow, for research funding, what would you do with it? Would you expand Galileo? Would you start a Galileo for larger distance detection?
It depends who the someone is. I briefed the US Congress on May 1st this year, and I asked for $1 billion to figure out unidentified anomalous phenomena. I said if you put good scientists on this task, they would solve the problem.
Oh, I didn't know. So great mind
Yeah,
things alike, think alike.
sort of Manhattan Project.
Okay.
If you define, but it will cost much less money than, let's say, the space. Going to the moon. But if the money came from a philanthropic organization, I would invest it in interstellar objects, not unidentified anomalous phenomena close to Earth. I would like to find many more. We have the Rubin Observatory in Chile, which cost close to $1 billion to the National Science Foundation, the Department of Energy, and it monitors the southern sky every 4 days with a camera of 3.2 gigapixels. I would like to have a copy of that in the northern hemisphere, because right now we're looking only at half of the sky. And this telescope can find an interstellar object every few months. And of course, as soon as we find alien technology among the rocks that are out there, I think we should allocate a significant fraction of our military budgets worldwide to a warning system around Earth. And that would mean $1 trillion a year, not $1 billion. If I'm talking about $1 trillion a year, which is about 40% of what we allocate to either killing other people or preventing others from killing us. Just think about it. $2.4 trillion a year. That's what we are doing.
And that would be for natural objects, natural asteroids as well, right? The collision.
Well, you don't know in advance. So you would put a set of interceptors and sensors that would monitor all the objects entering the inner solar system and maybe take a close-up photograph of them by coming close to them. And then making sure that it's basically a planetary defense warning network, and making sure that it's no threat to humanity. If these are rocks, we can easily figure out if they will hit the Earth. That was the thing that killed the dinosaurs 66 million years ago, an asteroid the size of Manhattan Island. But alien technology is difficult, much more difficult than rocks, because it could maneuver and it may have an intent. If it has intelligence, we all know that intelligent beings are much more complicated than physical objects.
Avi, the Manhattan Project analogy is interesting because really the only thing that made that possible was that there was a concrete existential risk, which focused.
That's what I'm saying.
Which
exactly.
Focused the mind. So,
yeah,
to sort of go in that general direction, you would probably need to be able to make a case that a technological signature has been detected, it is heading here, and there's a bit of a chicken and egg problem there, because
that's for
science.
That's for science. The chicken and egg problem is for scientists, astronomers that are using telescopes. However,
I just mean that you would need the resources.
No, I understand, but I'm saying that's true for scientists. Now I'm saying that in the context of national security, the resources are allocated at $1 trillion a year for the defense budget to monitor objects that might be of a national security risk. Okay, so this money is already there. Okay, $1 trillion a year, and in the process of monitoring objects that are a potential threat for national security, you might come across objects that are non-human. Okay,
yeah,
and so I'm saying if government has such information, they might be willing to go ahead and and pursue it.
Yeah, let me ask you
right
something.
now. Yeah.
Yeah, let me ask you something about what you said earlier. So, we're definitely very excited that you wanted to talk to us, but why would you spend 4 or 5 hours a day on podcasts and subject yourself to probably the kind of crap that you get from your colleagues as a response? Is it because of how important you think the question could be in a black swan kind of framing? Is it because of how much attention the public is paying to this, and you feel that you, as a scientist, owe the public an intelligent conversation about it? Is it sort of about getting young people excited? Um, because I'm assuming that the sort of public engagement, like we're doing here, comes at the expense of you having time to do your own work, unless you don't sleep, which which is
No,
possible.
it definitely, but I should say it's not a complete waste of time because I do get ideas from these conversations. But the main reason is that this is an extremely important question. Both scientifically, it can change, it would be the most important discovery that humanity ever made. So it's, it's the going back to Pascal's wager, that you want, even if the likelihood is small, it might be a very worthwhile thing to do. And it will, in addition to a contribution for science on a very important question, it's one of these transformative events that will change the future of humanity. And there aren't many such scientific questions. But even if, I will not find the evidence during my lifetime, and you can already tell that the fact that I get this exposure to the public, to the political system, does change the landscape. It attracts people to science. First, it gives the public a different view of science as, being on a topic that is of great interest to them, and also seeing me admitting what we know, what we don't know, is refreshing to many people. They usually are used to, rather than seeing the process of us admitting what we don't know and how we want to address it, they see the final product in a press conference, and sometimes it's wrong, and they feel that the scientists are treating them like inferior. That I don't see it that way. So I'm trying to approach it differently. And I'm not a popularizer of science. There are all these popularizers, Neil deGrasse Tyson, Brian Cox. They are trying to be liked. They will always say whatever is the most popular narrative within the scientific community. They will never say anything bad about string theory, because so these are, and so attracting kids to science, bringing a better, how should I say, a better view of how science should be done as a learning experience, I think is really important for me to promote, and I feel that it's worth my time, and
Yeah.
yeah.
One interesting difference, by the way, from the Galileo historical scenario is that the public at this point is probably a lot less interested in what the church has to say and a lot more interested in what you have to say.
There is another main difference. Galileo was the first to use a telescope to learn about, the sky, and they could easily shut him down so that nobody would listen to what he has to say. However, now there are, already with 3i Atlas, there were, even before October, there were 247 observatories around the globe that collected data on it. There is no way that any government can shut down that kind of information, right? So nowadays, the truth will come out one way or another. The only thing that those people that push back against me can accomplish is making the subject less popular within the scientific community, so that the assembly of data will be reduced, and we will not notice the anomalies as much, because we are confident that we have the right explanation as a comet, let's say, for any object that we see. So if you are sure that you know the answer in advance, you don't need to get data, and that's a way of keeping your ignorance. So they will slow down the process, but they will not eventually, we will find it out. There is no doubt in my mind. I hope it will be in my lifetime. I hope we will allocate billions of dollars to the search for technological signatures, and not just to the search for microbes, which is the obsession of the mainstream in astronomy right now. because throughout my career, and by the way, my career spans 50 years of science, and that is half of the modern history of science. So I've been around for half of the history of modern physics. I have a lot of experience. I've seen a lot of ideas that looked completely reasonable but were ridiculed by mainstream and then ended up being discovered and then celebrated. And then the young people that come into the field after the fact, they say, oh, of course, this is completely reasonable. They don't even know how ridiculed the subject was.
Avi, thank you so much. This was absolutely
Fantastic.
fascinating.
Yeah.
We're very grateful that you made the time. We know that you have a lot on your plate.
Thanks for
Looking
having
forward
me.
to your further discoveries in this field.
And
As I mentioned,
we'll watch out for the blue tie.
Yeah, stay curious. That's the most important thing. And philosophy was my first love, and I will never betray that love. So keep doing what you are doing as well.
Thank you.
you.
Thank you.